Hi everyone. Today we're going to look at using transformations to graph. And I'm going to use Desmos here and make sure that we see some patterns that are going on with what we call our parent function. So one of our parent functions is a quadratic. So y equals x. Let's bring up that squared. All right, let's look at it before we start doing some transformations with it. We notice that the vertex is at 0, 0, and that the pattern is over 1, up 1, over 2, up 4, right? On either side, the over 1, up 1, over 2, up. I know it looks like we're going, let's see if I can make it 1. There we go. Then we can see our pattern better. Over 1, up 1 on either side, over 2, up 4 on either side. Okay, so when I'm looking at the next uh, graph, y equals 4x squared, I'm wondering how that's going to look differently when compared to our parent function. And so we can see that the vertex is still in the same place. The only difference is that our pattern changed. Instead of going over 1, up 1, it's now, let's see if we can zoom, ooh, there we go. It's now over 1 up 4. And so this transformation is actually called a vertical stretch. That 4 made the graph more steep and more stretched vertically. Sometimes it's called a horizontal shrink because, right, looking horizontally, it got smaller. So either way, but most people say that's a vertical stretch. All right, what do you think is going to happen when we put y equals 10x squared in there? Let's go ahead and make your prediction. And of course, it's even more stretched. The pattern has changed. Instead of over 1 up 1, it's over 1 up 10. Let's see if we can see. Let's pull that out a little. There we go. It's over 1 up 10. It has become even more vertically stretched. So we start to notice, with a parent function, if you put a number in front of, let's say in this case, the quadratic of x squared, if you put a number right in front of that x squared, it's going to stretch it vertically. Well, what do you think is going to happen? Because I just said if you put any number in front of it, and that's not true. Because what happens if we put 1/2 in front of our x squared? Make a prediction before I click. And there we go. Actually, look at the red right there is our original um, parent function, and the purple is what we just put in. So the purple actually, when you have a fraction that's in between 0 and 1, it makes the graph vertically shrunk or horizontally stretched, either way that you want to use that. And so because the pattern is instead of over 1 up 1, it's over 1 up 1/2. Let's see if we can click on that. Yep, over 1 up 1/2. So also, if we had a negative, and we're going to look at negatives, even a negative 1/4 or a negative 1/2 or a negative 1/8, that would also be a vertical shrink or a horizontal stretch. All right, let's go back to our um, and double check that. All right, we talked about the pattern, corner points, we talked about that. That's just looking at the pattern. If you want to pause this, there are words that go along with what I was speaking about. You can pause that. Let me make sure we're still going. Okay, let's keep going. Now we're going to see what happens when we use transformations in a different way. So we're going to look at y equals x squared plus 4 and y equals x squared minus 3. So let's get rid of all these. Let's go back to just our parent function. And let's see what happens when we do y equals x squared plus 4. There we go. It's the same pattern because we don't have a number in front of the x squared, but that plus 4 just took our vertex and shifted it up. We call that a vertical shift, which is different than a vertical stretch, right? There's no change to the steepness of this graph, so there's no vertical stretch or vertical shrink, but there is a vertical shift up 4. So what do you think is going to happen when we put in a y equals x squared minus 3? That's right. That vertex has a vertical shift down 3. Now, in non-pandemic times, I usually have students just do this on their own and explore. So I'm sorry, it's probably not as fun with just watching me do this. So we went ahead and there are some words if you want to pause and write down those words, but we're just going to fly right through. I know that you did this in 2trig. What happens when instead of doing x squared plus number, we have the plus and the number inside of the parentheses where the whole thing is being squared. So let's see. Let's go ahead and we can even compare. Let's go ahead and do x squared plus 5. We see that's a vertical shift up 5. But what if y equals the x plus 5 is in the parentheses, and then we square the quantity? That looks totally different, right? So we can see in black, this is x squared plus 5, which just shifted the vertex up 5. But, so I'm going to get rid of that. But now we see that when the plus 5 is in with the x, it actually shifted the vertex horizontally to the left a negative 5, okay, or to the left 5. So this is a horizontal shift to the left 5. And it's always going to be the opposite of the number that we see here because negative 5 is what it would take to actually shift this back to 0. So that's why there's a shift of negative 5. All right, so what do you think it's going to do if I put a minus in there, right? If I say y equals, and then in parentheses, x minus 2, and then we square that, the whole quantity. Well, instead of moving it to the left 2 like we might think, this is actually a horizontal shift to the right 2. So let's see what we have back here. Oh, I didn't even have a plus. All right, so there we go. You want to pause it and write anything down, you can. All right, what if we just put a negative in front of the x squared? Do you know what would happen? I think most of you do. So let's go back to our parent function, and let's go ahead and put in y equals negative x, and let's square that. And we see that we have the whole graph reflected. So when we have a negative in front of the x squared, it's going to reflect the graph over the x-axis. It just totally flips it. And this makes sense. Whatever's in front of the x squared affects the pattern. So instead of like our parent function going over 1, up 1, we're going over 1, down 1, over 2, down 4. The negative affects our pattern by multiplying our pattern by a negative 1. All right, if you want to go ahead and pause and write that down, you can. All right, so it's not just with quadratics that these transformation rules work, also works with the square root function, right? And so what we're going to do is look at, let me flip to my notes so when I go to Desmos, I know what we're graphing. Let's go ahead and graph the square root of x on Desmos. All right, so we want to see that these transformation rules are the same regardless. So let's see how we do a square root. It should be here. There it is. All right, so we'll do square root and put an x underneath. All right, so that's what the square root of x looks like. This is considered the parent function. And so it makes sense that we don't even have a graph over here in the left area because x can't be negative. So there's, right, we did domain, so we know that x, if it's underneath the square root, has to be greater than or equal to 0. The domain does. And so that's why there's no graph over here. And it makes sense. You plug in a 0, square root of 0 is 0. You plug in a 1, square root of 1 is 1. There's our 1, 1. You plug in a 4, square root of 4 is 2. Oops, scooch it over, and that should be 4, 2. All right, so this is our parent function. Just kind of make sure that you know what it looks like. And let's start messing around with our parent function. Instead of just the plain old square root, why don't we go ahead and put a 4 in front of it? What do you think this is going to do to our parent function as far as shifting? Let's go ahead and put the 4 first and then hit the square root and then the x. It affected our pattern, right? So instead of normally, 0 times 4 is still going to be 0, right? But normally, a square root of 1 is 1. Well, now we have to multiply that by 4. 1 times 4 is 4. Square root of 4 is 2, right? But now we have to multiply that 2 by 4, which is 8. So the number in front is still following that rule of it will stretch it vertically. That is considered a vertical stretch there. All right, what if we put a negative in front of our square root? So let's go ahead and do that. What do you think is going to happen? Bloop, totally flips it. Let's get rid of there we go. So it's exactly the same graph, but it flips it over the x-axis. And it makes sense, right? Because when x is 1, square root of 1 is 1, but negative the square root of 1 is a negative 1. So we see that negative. That means it's going to, right in front of our parent function, that means it's going to flip over the x-axis. What about if we have the negative in a different place? Wonder if that negative is right there underneath, let's see, underneath the square root. So if the negative, note where, oh, I got rid of it, but note the difference between where that negative was, all right? So if the negative is underneath the square root, that's going to reflect the graph over the y-axis. It will flip it over to the y-axis. And it makes sense if you stop and think about it. All right. All right, so first you've got to remember what your parent functions look like, whether it's quadratic, absolute value, exponential. We didn't look at exponential, but you all know what exponential looks like, and the parent function for exponential is y equals 2 to the x. And we're going to put the rules together. So this is where you want to make sure that you stop and take good notes. I'm using a quadratic formula or a quadratic equation to emphasize what each part does, but this holds true whether it's absolute value, exponential, or square root function, okay? So if you see a negative in front of, at the very beginning, like right after that equal sign, you know that that's going to flip the parent function over the x-axis. If you see a number right after the equal sign, that affects the steepness. So if the number is like 4, that's going to make it have a horizontal stretch and be more steep. If the number is 1/2 or 1/4 or 1/8 or any fraction between 0 and 1, now I know the negative's separate, right? So now we're just focusing on the number, even if there's a negative there. If it's a fraction between 0 and 1, we know that that's going to be a vertical shrink, okay, or a horizontal stretch. So if the number's big, like 10, it's a vertical stretch. If it's a fraction between 0 and 1, it's a vertical shrink or horizontal stretch, right? It messes with the pattern. If we see a number right after the x, that's going to be a horizontal shift, left or right. And if we see a number at the very, very end, that's a vertical shift up or down. What I missed here, let me put that in right now. Wonder if you see a negative in front of the x, right? Yikes, this was missing. So let's talk about that. And that is that makes it flip over. So flips over the y-axis. So go ahead and add that to your notes. A negative in front of the x flips over the y-axis, just like we saw in our last example on Desmos. All right, pause that and make sure you take good notes. All right, put it all together. So wonder if we're going to graph this. The first thing I'm going to look at is I notice that the -5 means to take, if we're dealing with a quadratic, our parent function is, just a plain old, y equals x squared, so our vertex is normally on 0, 0, but that -5 says move the vertex over 5. The second, hold on, the second part of it, so it's this -5 minus 5 means move it to the right 5, and this +6 means move it up 6. So we'll go over 5, up 6, and there's our vertex. And then because, life is short, time is short, we don't have a ton of time. Let's go ahead and just do 2 points. So this -3 is what's going to mess with our pattern. So we have 2 ways to do this. All right, so we could do it logically, and that we know that normally, if we didn't have that -3 there, our pattern is always from the vertex. We go over 1, up 1, we put it there, and over 1, up 1, we put it there. But darn it, we do have that -3 there, which multiplies the pattern by -3. So instead of over 1, up 1, from the vertex, we're going to go over 1, down 3, and over 1 down 3. All right, let's see what I have behind here. Or another way to do it is just look at the two numbers on either side of the vertex. So the vertex is right there in 5. So you could plug 4 into the equation and you'd get a 3. Or you could plug 6, the number on the other side of the vertex, into the equation and you get 3. All right, I am doing this with my, all right, let's see if I can do this. I am not using the smartboard, so this is going to look a mess, okay? But go ahead and bring these all right, and make it look better than that. All right, obviously it should be a nice smooth curve. And that's it. Thank you for joining me. And if you have time, mess around with Desmos. I think that's a great way to learn, especially if you want to have fun with the y equals to the x parent function and mess around with that and see how each thing you do affects and moves the parent function. All right, thanks for joining me. See you in class.